problem identification. Electricity is becoming a rising problem as inefficient equipment, obsolete infrastructure, and a lack of knowledge led to excessive power use. Resin expand and negatively impacting the environment. Electricity in workshop is frequently caused by improper equipment utilization, keeping machinery left on during idle hours and insufficient monitoring system, creating a smart energy management system which programmable control can aid in the reduction of electricity use, optimization of consumption, and operating expense. People nowadays use a lot of energy everywhere they go, even in workplace to operate light. This results in high energy bill, which now increase in consumption, maybe due to the voltage of the light bulb or light being set too high. The next issue concerns safety precaution, which cover potential hazards such as asphalt, moving part, and unsteady installation or missing safety feature. Furthermore, the vast majority of problems are associated with equipment control. The workshop, as is common, requires sufficient lighting to facilitate repair. Lamp have an influence on workshop comfort and expensive bill rate when used excessively, but they provide ample light for repair or workshop activity. Human mistake account for the vast bulk of energy was in laboratories. A few lab personnel utilize electronic lighting and the equipment without remembering to turn off the power supply, resulting in significant electricity loss. This is a severe problem owing to human mistake. Paying the electricity bill might be rather costly.
Solution. It is critical that we employ a timer system in this specific case to regulate and optimize the length of lamp operation. This will ensure body energy efficiency and efficient and regulated management of the flow of electricity in the workshop. We also create a solution that has been suggested, which is to program a PLC to cut off the power supply to the electronic device at a specific time to ensure that the light is turned off. The work forgets to turn off the light after work or when they are done using the lab to avoid wasting electricity, since human error is the main cause of electricity loss in the lab. The timer is the PLC component that will be utilized in this approach. To avoid electricity, the time is programmed to turn on the lamp at a specific time and keep it on until the end of the designated period.
To make it easier or more visible of the functionality in the case study we made, this is an overview of our PLC circuit. For example, the first is where we can see the workshop is dark. So let's take the example because the workshop workers are not coming yet in the workshop. So for the second image is when the workers are already there, they will turn on the lights of the workshop and do their works. So the third one is where the lights will be closed automatically after working hours or after they're done doing their works due to the time that we set on the timer. To understand better, this is a further overview of our case study in PLC circuit. So we will move to the next part, which is PLC programming, where here we can see the I/O table, where the table is the data from the PLC circuit that we have made. This table aims to indicate the data used in each component or part in the PLC circuit. In this table, there is PLC, the address of each component, and the function of each I/O made. For example, the first input works as push button 1, which the address is 0.00. So this is the diagram that shows the PLC circuit of the lamp when it is being turned off, where we can see both push button 1 and push button 2 are not pressed at all. Next, this diagram shows the PLC circuit on the lamp when it is on running, where we can see only push button 1 is pressed to turn on the light system in this circuit.
This is flowchart if push button 1. Push button 1 is pressed and the lamp is on. And then the push button is pressed to turn off the lamp and finish. This is a push button flowchart on push button 2. Push button 2 is pressed, the lamp is on, the timer is begin to count, and timer finish to count and lamp turn off and finish.
Conclusion. In conclusion, careful hardware setup, wiring, comprehensive testing and medical troubleshooting procedure are required when installing a light timer in a PLC system. A solid and effective light timer system can be installed by following the step list, from assembling the part and installing them to verifying functionality and troubleshooting. Throughout the procedure, we regularly refer to paperwork and safety standards to guarantee trouble-free installation and to facilitate future maintenance. Successful implementation requires careful attention to detail at each phase, promoting electrical safety as well as operational functionality. It also includes creating a lighting timer system that uses Programmable Logic Controller PLC technology, providing great benefit for the efficient and controller use of light energy in various contexts. Intelligent scheduling of light timer provide optimal energy use and environmental condition. PLC Programmable Logic allow modification of various light operation based on unique demand, resulting in higher energy saving and comfort. This technical solution, however, is not without obstacle. Programming complexity and possible upfront and stress should be carefully evaluated, and company may need to invest in programming and training of maintenance personnel.
So we will be moved to the result section, where in this section I will show a PLC circuit demonstration video. So let's take the same example that when the workers have not come to the workshop, the lights are turned off. After the workers come, they will press the light button, which is push button 2, and when they have finished their work, for example, if the work time is over, the light will be closed by itself automatically. We take this 10 seconds example just to show the function of the PLC circuit. The truth is that this timer is set for 8 hours, which is in line with the working hours. This is a picture of result of the PLC lamp circuit that we made. It consists of a circuit that is not running and a circuit that is running.